Hello, Ben Davidson.
Hello, Ben. This is Randall Carlson.
It would appear to many observers that you have become interested in something we are all interested in.
It's just become one of those things where you know that it's there, you know that it's important, and finally you go, okay, I've got to look into this. I learned about the Carrington event, and I learn about solar flares and coronal mass ejections and all of this, and I'm realizing, well, if we're going to really try to truly understand global change, we have to be looking at all of the factors. And my gosh, what could be a more important factor than the sun? One of the things that I guess I kind of stumbled on, and you know that I'm quite fascinated with comets and the role of comets. And at some point, I guess a couple, maybe 3-4 years ago, as I began to look into a lot of the satellite surveys of our near-Earth cosmic neighborhood, this is when I really kind of came to the realization that there were the Kreutz category of comets, which are the sun grazers, and how many of them there are, and that they may be related to responses in the solar magnetic field as they accelerate into the sun at the end of their lifetime. And I had no idea how many of them there were. There's hundreds of them now have been documented.
The observers have found themselves similarly stumbling into Randall Carlson territory here. A number of the studies which, I briefly mentioned to you on the phone, the one about how they redated the Tibetan ice caps using krypton isotopes, and all of a sudden what was thought to be more than 500,000 years old is potentially from the Younger Dryas, or how potentially during the Younger Dryas the Fennoscandian ice sheet in Norway and nearby regions didn't have ice. There's so many questions that we've been running up because we are the journal hawks that we are, and there's just so much that we're very happy that you're going to be more involved online, and that you might even be able to help us out with a lot of these questions that really don't do more for us but tell us that, hey, wait a minute, this is showing that the story's got holes in it, and it seems to point in the direction of the kind of stories that we tell on our channel and that you tell of the past as well. Specifically, this story of how rapidly the ice age comes on because we have to have heat to get all the water into the atmosphere, but then we have to have cold to freeze it. And as you said the last time we talked, they used to be able to say it took 100,000 years, and that's just not going to work anymore.
Right, yeah. With all the various dating technologies, everything is turning out to be a lot quicker. Because for example, there's a whole body of evidence suggesting that most of northern North America was forested and non-glaciated between roughly 30 and 50,000 years ago. And I say that's roughly, but looking at the stratigraphic evidence, there is pollen and seeds and evidence of pretty much boreal forests growing in a lot of places where, let's say, between 20 and 25,000 years ago, there might have been 1,000 or thousands of feet of ice. So instead of there being one consistent ice sheet over 100,000 years, the whole situation seems way more dynamic than that. That the ice has waxed and waned on a much greater scale than had previously been imagined, and it has done it a lot quicker. So with the advent of various dating technologies, even if those dating technologies still need refinement, which I'm sure they do, it still does appear that everything has happened considerably faster than had been imagined. It's an umbrella site that covers everything I've been doing and exploring for the last 3, even 4 decades. It's going to certainly be looking at global change, but then the other how that affects the rise and fall of civilizations. If so, the balance of the biosphere, the mass extinction events that have played such an important role in history. And, I'll be looking at all kinds of things. A lot of the things that you guys look at, I'm sure there's going to be some overlap, especially now that I'm doing this sort of upgraded investigation of the role of the sun. I'm very interested in the interface between modern science and ancient science, ancient wisdom, if you want to call it that, because I do believe we have inherited a very sophisticated legacy of knowledge and a way of organizing knowledge from distant ancestors. And so I'm very much about incorporating those kinds of things into the investigations to come up with a model that recognizes there's a lot more scientific validity to some of the traditions that have been handed down to us from ancient times, and that we could learn a lot from those traditions. But also exploring, cutting-edge scientific areas in geology and archaeology and paleontology. I travel a lot and I explore the evidence as preserved in landscapes for past changes. And the kinds of changes we're talking about do leave very distinct signatures in the global landscape that can be deciphered. So a big part of what I have been engaged in, I would say, going back to the 1980s, is this attempt to interpret or to translate the symbols, the geological symbols that are impressed into the landscape, and understanding that those are actually telling us a story, that there's a story that's preserved in the global landscape that's been there, if we want to look at the most recent incarnation, has been there for between 12 and 13,000 years. And if we go back to the Younger Dryas, we're basically seeing that the food chain was sort of, I would say, decapitated in a way. A lot of the climax species, particularly the large mammals, quickly succumbed to whatever was happening. So we had something like 100 or more species of megafauna that did not survive the Younger Dryas. They came up maybe in the millennium before they perhaps started going into decline, because it seems like what we're looking at that transition from the Pleistocene epoch to the Holocene epoch, the pivot point was the Younger Dryas. And during that, at the onset of the Younger Dryas, there was over 100 species that did not survive that transition. The transitions that triggered these were almost virtually instantaneous. There were sweeping and dramatic global changes that affected the ecology of the entire planet. So then that brings us back to the question of what is driving the Younger Dryas? What is driving changes of 8 to 10 degrees centigrade in 5 years or less? And here's the thing, Ben. You could go and visit a trauma on Earth that would cause a major loss of species, such as occurred during the Younger Dryas. Now, if something equivalent to the Younger Dryas happened today, I think we could safely say it would pretty much be impossible for our modern civilization to recover. When we have a local or a regional catastrophe, a volcanic eruption, a hurricane, a great earthquake, or even widespread fires, generally they're local or they're regional, which means that there's going to be an intact base from which resources can be derived to facilitate recovery of the whatever was destroyed in that particular catastrophic event. When we look at the Younger Dryas, though, we're looking at a global event. We're looking at an event that caused complete ecological reorganization of the planet. And what you had was pockets of, or refugia, as you might want to call it in ecological terms, where particular species managed to survive. And from those pockets, from those places of refuge, basically what you had was biological diversity then radiated outwards to reclaim the traumatized areas.
It's a little bit of a different story when everyone's in trouble. There's nobody who's able to come help. Your ability to help yourself is significantly declined, and then you sort of can easily see how afterwards only little tiny pockets, little needles of survival amidst a haystack of disaster would be left.